Welcome to another segment of electronic devices. And today we are going to discuss about photodiodes. In this section, we will talk about its functioning, characteristics along with applications. So let's get started. A photodiode is also a PN junction semiconductor made of P type and N type extrinsic semiconductor material, and it is specially designed to operate in reverse bias. When the device is illuminated, the current varies linearly with the light flux. The device consists of a PN junction embedded in a clear plastic case. Radiation is allowed to fall upon the plastic surface across the junction. The remaining sides are painted in black or enclosed in a metallic case. Now we will talk about the schematic symbol and biasing of photodiode. The schematic symbol and the basic biasing arrangements of photodiode is displayed. The output voltage is taken from the load resistor R, which is connected in series. Now, talking about working principle, when the PN junction is in reverse biased, a reverse saturation current flows due to thermally generated holes and electrons being swept across the junction as the minority charge carriers. With an increase in temperature, the junction, more and more electron hole pairs are created. As a result, the reverse saturated current I naught increases. The same effect can be obtained by illuminating the junction. When the light energy bombards the PN junction, it dislodges the valence electrons. It happens due to the generation of more and more charge carriers. The dark current is the current that exists when no light is incident. The current becomes zero only with a positive applied bias equal to V0. An increase in reverse bias voltage does not increase the reverse bias current because all available charge carriers are already being swept across the junction. The reverse saturation current I naught in PN junction diode is proportional to the concentration of PNO and NPO of minority carriers and the N and P regions respectively. At this condition, the current under large reverse bias is I, that is equal to ISC plus IO dash, where ISC is the short circuit current that is proportional to the light intensity. Hence, VI characteristics that is given by I, that is equal to ISC plus I naught multiplied by 1 minus e to the power V by eta VR, where I, ISC and I naught represents the magnitude of the reverse bias current, and V is positive for a forward voltage and negative for a reverse bias. The parameter eta is unity for germanium and 2 for silicon, and Vt is the voltage equivalent for temperature. Now, the applications of photodiodes. Since the rise and fall times are very small for this device, it can be employed for high-speed counting and switching applications. Typically, photodiode applications include detection, demodulation, switching logic circuits that needs a stability at a high speed, character recognition, optical communication equipment, IR remote control circuits, encoders, etc. An alarm system using photodiode is displayed. When the light beam gets interrupted, the saturation current falls to dark current and sounds the alarm. With this, we have come to an end of this topic, and today we learned introduction to photodiodes, schematic symbol and biasing of photodiode, working principle of the diode, and the applications with photodiodes. Thanks for watching the lecture. We will back with another topic soon. Bye.